I will apply the circular pattern feature to the spur gear with spoked model. The sections that will be duplicated are the spoke and the teeth of the gear. For this step, I will start with the spoke first. In this model, there is already a cut feature named Cut Extrude 3. I click one face of this cut. We can see that the selected face is highlighted. At the same time, Cut Extrude 3 in the design tree is also highlighted. This shows that the face belongs to the Cut Extrude 3 feature. Now I click Cut Extrude 3 directly in the design tree. In the model area, we can see that this cut is a single feature named Cut Extrude 3. I will duplicate this cut in a circular pattern. This will leave solid sections that form the spokes of the gear. To begin, I go to the Features tab. Then I click the small arrow under Linear Pattern and select Circular Pattern. In the Property Manager, I make sure the Features to Pattern field is active because the cut was created as a separate feature. After that, I click the cut on the model, which is Cut Extrude 3. Next, I need to define the reference axis. In Direction 1, I click the Pattern Axis field. Then I select this circular edge. Once the axis is selected, a yellow preview appears on the model. We can also see the Direction 1 box displayed on the screen. To make it clearer, I change the view to Front View. Next, I need to set the angle and the number of instances. I want this cut to be arranged in a circular pattern with the same angular spacing between each instance. For this reason, I select the Equal Spacing option. By default, the angle field is set to 360 degrees, and the number of instances is set to 4. This means the feature will be patterned 4 times, evenly distributed around a full circle. If I change the angle to 180 degrees, the feature will only be duplicated over half of the circle, but the angular spacing between each instance remains equal. The larger the angle value, the wider the circular area used to arrange the feature. In other words, the angle field controls the total angular range, while the spacing between features is automatically kept equal when using equal spacing. For this example, I set the angle back to 360 degrees. Then I change the number of instances to 6. I click OK to complete the operation. Now we can see the result. The cut has been successfully duplicated into 6 instances with equal angular spacing. I change the view to Dimetric. Next, I will add fillets to smooth the spoke edges. In the Features tab, select Fillet. I zoom into the lower area of the model. Then, I select the edge between the spoke and the gear base and choose the right loop option. I do the same for the other edge between the spoke and the base. I adjust the view to reach the other edges that have not been selected yet. For this fillet, I keep the radius at 10 millimeters. After that, I click OK. Next, I select Fillet again. This time, I select the edge between the spoke and the gear hub and choose the left loop option. I repeat this step for the other edge between the spoke and the gear hub. Then, I rotate the view to reach any remaining edges. I continue rotating the model to check the fillet preview. For this fillet, I set the radius to 5 millimeters. Then, I click OK. Now, I add the last fillet. I select the spoke edge and choose between right feature and part. Then, I repeat the same step for the other edge. I rotate and adjust the view to check the fillet preview and make sure no edges are missed. If there are still edges that are not selected, I click on those edges to add them. I rotate the model again, and now all the required spoke edges are selected. For this fillet, I set the radius to 3 millimeters. Then I click OK to complete the operation. Now the spokes look smoother. I change the view back to dimetric to see the overall shape of the model. In the design tree, I group the features that form the spokes to keep everything organized. I click Cut Extrude 3, then hold the Shift key, and click Fillet 3. After that, I right-click, select Add to New Folder, and name it Spoke. Next, I will apply a circular pattern to the teeth of the gear. I want to duplicate one tooth evenly around the cylindrical base of the gear. I zoom into the tooth area, then I click on one of the tooth faces. Notice that the selected tooth face is highlighted. In the design tree, the feature that creates it is also highlighted, and it is named Base. Now I click this feature. From the model, we can see that the tooth and the cylindrical base are created as one single feature. Meanwhile, the fillet named Root Radius is created as a separate fillet feature, on this side and on the opposite side as well. All right, we will try the circular pattern in this condition. In the Features tab, I click the small arrow under Linear Pattern, then select Circular Pattern. This time, in the Property Manager, I choose Faces to Pattern because the tooth is not created as a separate feature. Next, I select the tooth faces that I want to duplicate. First, I select the outer tooth face, also called the top land. Then I select the side face of the tooth, or the flank, on this side. I rotate the view and select the flank face on the other side. In addition, I select the fillet face, or root radius, on this side. I rotate the view again and select the fillet face on the opposite side. To make everything clearer, I change the view to dimetric so the entire gear is visible. The next step is to define the pattern axis. In direction 1, I click the pattern axis field. This time, I will use a temporary axis as the pattern axis. To do this, I move the cursor over the cylindrical surface that has the appropriate center axis. For example, when the cursor is placed over the outer surface of the cylindrical base, a temporary axis appears at the center. When the cursor is placed over the outer surface of the cylindrical hub, the temporary axis also appears at the center. The same happens when the cursor is placed over the inner cylindrical surface. However, if the cursor is placed on a circular edge, the temporary axis will not appear, either on the hub edge or on the base edge. The temporary axis can also be shown from the Hide Show Items menu by activating View Temporary Axes. I select the temporary axis at the center of the cylinder as the pattern axis. Now, a yellow preview and the Direction 1 box appear in the graphics area. I keep the equal spacing option selected. This option ensures that the teeth are evenly spaced around the cylindrical base. I keep the angle at 360 degrees, which means the pattern will cover a full circle. Then, I want the gear to have 80 teeth, so I set the number of instances to 80. I click OK to complete the operation. After the pattern is created, the temporary axis is no longer needed. Go to the Hide Show Items menu and click View Temporary Axis to hide it. In the design tree, the newly created circular pattern feature is visible. I click the feature, then click again to rename it to Teeth Sur Pattern. Next, I adjust the visual appearance of the model. Open Apply Scene, then select Plain White. Then, I go to Display Style and choose Shaded. Don't forget to save the result by clicking Save. Now, we can see the final spur gear with spoke model like this.